Students, now we'll see about open circuit. Open circuit. What is open circuit? When we say there is some circuit as called open circuit, whenever there is some discontinuity. So here there is a voltage source. Here we have a resistance. Okay, fine. So then here the circuit is not continuous. Here there is some open or discontinuity which is happening from point A to B. Fine. So and here we have the connectivity from here to here. So when we have such discontinuities in the circuit, so then such circuit is called as what? Open circuit. So because of this open circuit, the current will not flow, because current flows only in a closed loop, isn't it? So we know that current always flows in a closed loop or closed circuit. We can say it as, right? So here we have applied some voltage, and because of this voltage, some current has to flow. But here the current will not flow. Why? Because there is some open in the circuit. So there is some opening in the circuit, and because of this opening in the circuit, this circuit is called as what? Open circuit. And in an open circuit, current will not flow. Current will be zero, and across this points A and B. So here it is open. Fine. So because of this open circuit, because of this opening here from point A to B, there will be a resistance which will be dropped across these 2 points. That will be infinity or infinite resistance. Countless amount of resistance will be found across these 2 points A and B. Is that okay? Fine. Because of this infinite resistance, all of the applied voltage will be dropped across the resistance or across these 2 points A and B. And this resistance which is there here, R1, is like it is not there. It acts like it is not there. Fine? Because here this open circuit resistance is infinite. So this will become countless. Is that okay? So this is very huge. This is not like considered. So all of the voltage which has been applied over here, it will be dropped across the points A and B, and whatever voltage you have here, you will be finding that same voltage across these 2 points, and this resistance acts like as if it is not there. Okay, fine. Then okay, so this is the story about your open circuit. Whenever there is an open circuit, current will not flow, and across the points, or we can say across the open circuited points, we can find infinite resistance, and all of the applied voltage will be dropped across that point. Is that okay? And if you have any of the resistance in the open circuit, they are like as if they are not there, because there is no current flowing, and what's the use of that resistance over there, isn't it? So it is like it is as if it is not there. Okay, fine. So this is how we can go for, and here we can say some example. So if I have applied some voltage of 5 volts here, I have given some example over here. Here we have 2 resistances. One of the resistance of 1 kilo ohms. This is 2 kilo ohms resistance, and here there is an open, and I have mentioned that as what point A and point B, and here I can find infinite resistance. Fine. So now this applied voltage is going to drop. All of the voltage will be going to drop across this point. Why it is happening so? Because here, because of this 5 volts voltage source, there has to some current has to flow, isn't it? Because here there is open, the current will be 0. Current will not flow. I will be 0. Because of this open circuit, the current will be 0, and current will not flow in this circuit. Because current is not flowing, voltage will not be dropped. Okay, and here I can find infinite resistance, because current is not flowing, voltage will not be dropped. So that is one reason. Fine. So and because here we have got infinite resistance, because of this open in the circuit, here we have infinite resistance. So all of this voltage will be dropped here. So these 2 resistances, 1 kilo ohms and 2 kilo ohms resistances are acting as what? As if they are not there. And these 2 points will be equivalent to these 2 points, because here we have 5 volts of voltage drop. So applied EMF applied is what 5 volts. So this all of this voltage will be dropped here, and across point A and B measure what? 5 volts of voltage. Is that okay? So when all of the voltage is dropping here means what? These two are not there. Isn't it? Isn't it or not? Yes, in that case. Because here we have infinite resistance. These two resistances will become what? I said, they are not there. Right? So they will become very small compared to this resistance. And all of this voltage will be dropped here. And they are like neglected. Fine. So now coming to a short circuit. Short circuit is what? Short circuit is what? There is some continuity. There is some continuity from one point to another point, and it is called a short circuit. Here, open circuit is discontinuity. Short circuit is what? It is a continuity. Yeah. So opposite to open circuit, we have what? A thing called as a short circuit. So what happens here in the short circuit? We will see here. So here I have shown you an example where we have a voltage source V, and here we have what? This is positive end of this. This is its negative terminal. You can say it as. So here the current I has to flow, isn't it? Some current I is flowing like this, and it will reach to negative of the voltage supply. So here some current is flowing, and here we have a resistance R1, and here we have resistance R2. Now what we did is, so we have made some short circuit here. From here, point A to point B, I have made a short circuit. Short circuit means what? I have shorted. I have connected point A to point B with some wire. I have used some copper wire, and I have short circuit across this resistance. So then here, what happens is, what I can say here is, so the current which flows here, it comes like this, and it flows through R1, and when that current comes here, so what happens here is, when that current comes here it has got two things to do, isn't it? So here it has to decide which side to go. Fine. And current always finds for what? An easy path to flow. Is that okay? It always finds for an easy path to flow, and when it comes here, it will find zero resistance here. It will find some which resistance here. Whenever there is some zero resistance, it will find the path of that zero, like it will find that zero resistance path, instead going for a resistive path. Here it faces what? Lot of opposition. Here there is no opposition, isn't it? So it finds an easy path to flow, and when the current comes here and when it comes to point A, it will directly go to point B through this way, not through R2, and it reaches B and it reaches to negative of the power supply. Is that okay? Whenever there is short across some resistance, so this resistance acts as if that is not there, and across short resistance will be what? 0 ohms. Is that okay? Whenever we have some short in the circuit, so that offers 0 resistance. Whenever there is some open in the circuit, it offers infinite resistance. Whenever there is some short in the circuit, it offers what? 0 resistance, and the current will flow through that path instead of going for a resistive, some opposing or through a path wherein it can face some resistance. Fine. So when it comes here, it will find this path to flow, and it makes this resistance this will have what? 0 resistance. And whenever I can go for now the current is flowing like this in this circuit. So now total current or maximum current what I can expect here is all because of this applied voltage divided by the resistance R1. R2 is not coming into existence because because the current is flowing the it is flowing through this short circuit. So whenever there is some short circuit, the resistance offered will be 0 ohms, and it flows like this, and this R2 is as if it is not there. That resistance is not considered whenever there is some short circuit and maximum current can be said as what? The applied voltage divided by the resistance. Only resistance which is there in the circuit is now R1. R2 has gone. Because of this short circuit, current will find this easy path instead of going through R2, and R2 will not it is like as if it is not there. Fine? Yes. Now that also we can prove with this example. Here coming to this R2 and this resistance, if I have to go for this and this R2 is in parallel with this short, isn't it? So if I have to calculate the resistance across these 2 points, R2 will be, if I have to find the parallel resistance, I will be considering R2 and this short circuit as what? 2 parallel, 1 parallel, 2 parallel things or 2 parallel resistances. This offers 0 resistance. This has what certain resistance R2. If I have to calculate the parallel resistance or equivalent resistance, so then R effective. If I have to find out here, so then I have to go for what? R2 parallel with 0 ohms of resistance, isn't it? So now this is what? R2 into 0 divided by R2 plus 0. Then I'm multiplying with 0. The resistance will be what? 0 ohms. So the effective resistance which will be offered here will be what? 0 ohms. The R2 acts like as if it is not there. Fine. So in this way, I can go for what? Some short circuit. Whenever across the short circuit, the resistance offered will be what? 0. And if we have some resistance over there, so that acts as if it is not there. And in this way, we can go for what? A short circuit and open circuit. Fine.